Despite the name, advanced power management is no longer the standard. One of the issues with APM, which is the acronym for Advanced Power Management, is that it requires specialized settings in the BIOS. On the latest Ubuntu systems, the apmd command returns the no APM support in the kernel message. In other words, on the standard Hardy-Heron release, APM can't be enabled unless you make strange modifications to the kernel. But as APM is still explicitly cited in the UCP curriculum, you still need to know a bit about how this works. Advanced Power Management events are categorized as configuration files in the etc/apm directory. As you can see, there are several subdirectories in that directory. Files in the event.d subdirectory relate to events associated with hard drives, laptop power modes, and modem connections. In the other.d subdirectory, if there are any files there, they'll relate to APM events that do not fit into any of the other categories. Files in the resume.d subdirectory naturally relate to resume events, such as sounds that you may hear when a system resumes from a sleep state, and things that might happen to the hardware clock. Jumping down a bit, files in the suspend.d directory are sort of the opposite of files in the resume.d directory, as they relate to sound events and what happens to the hardware clock when the system is suspended. Files in both these directories may call scripts in the scripts.d directory. If you have an older system where advanced power management is or can be enabled, you can look for APM messages related to the boot process. They're available in the var/log/dmesc file. As advanced power management is essentially obsolete today, that's about as far as I can go in this video. While APM is explicitly cited as part of the UCP curriculum and is therefore fair game for the exam, I believe the developers of the UCP exam do an excellent job keeping their questions up to date. So whether you study more about advanced power management as it relates to Ubuntu Linux is now up to you. ACPI files in the proc/ACPI directory. The Advanced Configuration and Power Interface, ACPI, is well documented in files of the proc/ACPI and sys directories. However, the UCP curriculum suggests that you should know the files in the proc/ACPI and the sys power directories. Examine the files and directories in the proc/ACPI directory. While still in common use even today, the settings in these files were originally used for Linux kernel 2.4. New ACPI systems create settings now in the sys directory, as I discuss in another video. Back to proc/ACPI. Let's examine these directories and files in a bit more detail. Let's start by looking at the AC adapter subdirectory. As you can see, this says that an AC adapter is online, meaning it's connected to the system. If it weren't connected, it would be offline. The alarm file would include the date and time configured for a system wake-up. If the date makes no sense, then there's no wake-up scheduled. If you have a battery, say this is a laptop system, there'll be batteries with alarm, info, and state files in battery subdirectories. The subdirectories you might see in the button subdirectory depends on the hardware that's available. You may see subdirectories related to lid, power, and sleep states. The event file is sort of a placeholder for ACPI events. It can't even be read by the root user. Next, the fan subdirectory notes whether the fan is off or on in the fan/state file. But fans don't exist on all systems. Many laptops don't have fans. Virtual machines generally don't configure fans. The info file includes the date associated with this particular ACPI package. The power resource subdirectory includes power status files, but the configuration therein may be superseded by other files. The processor subdirectory includes information on the status of CPUs. If there's more than one CPU, they're labeled as such. The first CPU would be labeled as CPU 0, CPU 1, and so on. Or if you have a multi-core system, CPU 0 would be the first core. The sleep file includes sleep states, which I've discussed in another video. In the thermal zone subdirectory, you'll be able to find information on the system temperature. In the video subdirectory, if you have a graphic card that so supports it, you'll get more information about video card information files. The wake-up file gives you information about hardware which can be configured to wake the local system. More on ACPI configuration. First, the current standard for ACPI configuration specifies the use of the sys directory. This system was first introduced for kernel version 2.6. But yes, perhaps the majority of ACPI-related files are still located in the proc/ACPI directory, and I discuss those in another video. But this video is focused in part on the sys directory, and the UCP curriculum limits this coverage even further as it specifies files in the sys/power directory. I'll cover 5 files in this directory, as shown here. Depending on the capabilities of the system, some of these files may not appear for you on your PC. Let's start with the disk file. It specifies supported power modes for the disk. The image file, or image_size file, specifies the amount of memory dedicated to a hibernate image, which saves your system in the case of a hibernate command. The PM_trace file is used to control the last power management event. The resume file, in a cryptic format, and that detail is not too important, specifies the location of the swap partition. Finally, the state file specifies the system, in this case the disk, to which power sleep states can be applied. In other words, the hard disk can be put into standby. In some cases, your system just doesn't work with ACPI. Perhaps you have a video card that can't handle it. If that situation applies to you, you can disable ACPI during the boot process. To do so, you'll need to enter the grub menu after booting begins, and that means you press escape at the appropriate time. Here's the grub boot menu for the Hardy Heron release. In my case, the boot menu is password protected, so I have to press P first. I enter the password, and now I can highlight the desired stanza and edit it. I press D. To add the command which disables ACPI, in other words, no ACPI, I have to highlight the kernel command line. I press E and then add no ACPI to that line. As an alternative, ACPI equals off works equally well, but no ACPI, it's what's specified in the UCP curriculum. But don't make this change permanent just yet. Be aware, no ACPI may also disable other ACPI-capable peripherals. But if everything works out, you can make this change permanent by editing the appropriate stanza in the boot/grub/menu.lst file. UDEV and the driver manager. The UDEV system means many device files can be dynamically created whenever appropriate hardware is detected, whether it be during the boot process or with hot plug hardware. For example, when I attach a USB key to my desktop system, it's automatically seen as the third SATA drive. Device files are then created in the /dev directory with names such as dev/sdc1. UDEV works with configuration files in the etc/udev directory. Looks pretty simple. It starts with the standard configuration file in the etc/udev udev.conf file, and all that does is specify that log messages of an error level are sent to appropriate log files. The strength of UDEV comes in its rules in the rules.d subdirectory. That looks like a lot of rules. Let's take a look at the 90-modprobe.rules file. As the name of the file suggests, when media is detected, it runs the modprobe command with appropriate drivers. So if you have a hot plug tape drive that's detected using the UDEV system, the modprobe command is automatically run to load the driver, enabling immediate communication with your system. To see what the UDEV system has already detected, say with the local CD drive, let's try the UDEV ADM command, ADM being short for administration. We'll query for all information on the system with device name dev/cd-rom. And I have to remember we're querying for all information. There we go. This tells me more about the device file, the actual device name, and related environment variables that are set by UDEV. If you want to monitor changes dynamically, try the UDEV monitor command. have a USB key or other hot plug device at the ready. Plug in that hot plug device. Watch the messages scroll across the screen. Unplug that hot plug device. Watch as more messages scroll across the screen. Compare those messages to what you see in the var/log/messages file. They should now look familiar. Just be aware, while the udev monitor command is what's specified in the UCP curriculum, it's functionally equivalent to the udev adm monitor command. Next, there's the driver manager. I have it in a GUI screen. It comes up on the screen in the hardware drivers window. As listed in the UCP curriculum, the driver manager is the management tool for proprietary hardware drivers. In most cases, mine included, it'll be blank. As Ubuntu has made so much progress with hardware, few proprietary drivers are required. It's to the point for the Hardy Heron release, where the restricted repository, which would have these drivers, has fewer than 40 packages for less than 10 hardware components. That's tremendous progress. So for most users, the hardware driver screen will appear blank. You also need to be aware that this screen can be started from a command line in a GUI desktop with the jockey-gtk command. If you do have any restricted drivers, they can be enabled or disabled through this GUI window.